Okay, this next problem's a little bit cramped for space. So first of all, I'm just going to kind of look at the diagram and think through some of the things that I know are true. It tells me that two of my lines are parallel. That's what, and it says it here. I guess I'll circle that in green. These lines are parallel, and that's what these triangles mean, right? It means that this one line BT is parallel with PF. Those two lines fit the definition of parallel lines, whatever that may be. And if I look at the parallel lines, one of the things I want to point out is that there's two different transversals, right? There's this transversal that goes from one parallel line to the other. And while I've got that marked, I want to just point out that this angle, right, is congruent to this angle, because whenever parallel lines are cut by a transversal, their alternate interior angles are congruent. Now my other transversal is this. I'll write it in blue. This angle, and if I look at it, going from the transversal to the parallel line, this angle and this angle are also congruent. So this statement that I've got two parallel lines is kind of powerful because it gives me two different pairs of congruent angles, and I can use that alternate interior angles theorem. So that's what we're given to start with. That looks like it's the only thing that we're given. Oh, no, there's one that's given. I should look closely. The other thing that's given is that these segments, right, for example, from A to F and from A to B, those segments are congruent to each other. And I think that's the only thing that we're explicitly given from that diagram. So if I look at it, first of all, we start with this PF is parallel to BT. Okay, well, the fact that that was parallel was because that was given. Now, the next thing it says, oh, alternate interior angles are congruent. So I could point out one of two things, right? There's two different pairs of angles that are congruent because of those parallel lines. And I could either say, for example, angle F is congruent to angle B, right? Angle F is congruent to angle B. Or I could also point out that angle P is congruent to angle T. Both are true with these parallel lines. So we're probably going to need one of those statements, and to be honest, I'm not sure which yet. So I'll just leave that on the table. This is interesting. This says vertical angles are congruent. Well, the only vertical angles that I have in my triangle, in my diagram, are the ones that are located right here, right? This angle and this angle are both in the triangle, and in one in each triangle, and they are vertical angles. They fit the definition, right? Two lines intersect, they're the ones that are non-adjacent angles. So those are vertical angles, and vertical angles are always congruent. That's this vertical angles theorem. So I'm going to go ahead and include that, and I'll call them angle PAF, angle PAF, and that angle is congruent to angle tab, angle TAB. Now the important thing here is that I have to have A in the middle. I could have actually switched the order because I'm not talking about congruent triangles yet. The other thing that's important is I can't just say angle A is congruent to angle A because I don't know what angle A I'm talking about. It turns out there's at least four angles right there that are meeting. So by saying angle PAF, I'm very clearly talking about this angle, and when I say angle TAB, I'm very clearly talking about this angle. So those angles are congruent because vertical angles are congruent. And at this point, I think I'm ready to decide which of the other two angles I need to mark as congruent. Oh, you know what? I bet let's include the sides here. So let's do this. This segment FA is congruent to segment I'll call it BA, and that's given from the diagram. I can tell from the tick marks that they're just given as congruent. So as I look at this diagram now, I think I'm ready to make my decision. I just want to point out the reason I'm supposed to use for the end of the proof is angle side angle. So if I come back up and look at my diagram, I can see I've got angle, and then there's this side, And then, yeah, I can see what's going to happen here. I've got this angle, and then I got this side that connects them, and then this angle. So I'm going to be using angle, side, angle. So the angles I need congruent still are this angle and this angle. We need to get those the same. Then I would have this angle, side, and then this angle. And on the other side, it would be the same angle, side, and then the angle. So we're ready. So I need to point out that angle F and angle B are congruent. Now, it turns out that they are alternate interior angles, and it also turns out that those lines were parallel because you can see it's given right there. So I'm just going to say angle F is congruent to angle B. Now, you may be asking yourself, why are you just using F and B here when over here you said you couldn't use A? When I look at vertex F and B, there's only one angle there, right? So there's no ambiguity, so I could refer to the one as F and the one as B, and that's perfectly fine. So I just have angle F and angle B, and they are alternate interior angles when these parallel lines, here they are parallel lines, parallel line cut by this here transversal, and you can see that's alternate interior, that's alternate interior. So they exactly fit that. So now it's just a matter of, you can see I've got an angle, I've got the side, and here is another angle, and the order that they are in the diagram is actually angle, side, angle. So let's go ahead and just write out which two triangles are congruent. So if I look at it closely, I could say, for example, triangle F and then to A and then to P. And if I did that, that would go with triangle. Let's see, that would go with B and then to A and then to T. So that's one way I can do it. And to be honest, there's plenty of ways as long as F and B are together, P and T are together, and the angle A is together. So I'm just going to go ahead and say triangle. I'll do FAP, triangle FA. P is congruent to triangle, and as I write this at F, let's see, FAP, FAP, FAP is going to go with BAT, triangle BAT, triangle BAT, and we angle. So fabulous. For some reason, OneNote's not redrawing itself. There it is. It's all there. That is the only flowchart proof we had to do for this test. Question number